Now, more than ever, we are concerned with reducing the impact we have on the environment by bringing down emissions from the electricity we so desperately depend on. A fuel cell is a device that is characterized by the electrolytes. For example, solid oxide fuel cell, polymer electrolyte membrane fuel cell, phosphoric acid fuel cell, alkaline fuel cell, and direct methanol fuel cell. But how do they work, I hear you ask? A SOFC in action, fueled by hydrogen for example, and using air as an oxidant, this electrochemical reaction is triggered in the cell. Oxide ions produced by the cathode travel through the electrolyte to the anode to react with the hydrogen ions and form water. Meanwhile, a flow of electrons, which provides electricity with a byproduct of heat, is also produced.
The ionic mobilities of ions is due to the high operational temperature of the fuel cell. However, depending on the setup, the fuel cells with lower operational temperatures are possible. At the moment, many companies are engaged in research and development of solid oxide fuel cells.
Redox Power is a startup spin-off from the University of Maryland. We are creating a fuel cell called the Cube that is claimed to cost $800 per kilowatt once built, whereas the popular industry competitor, Bloom, costs $10,000 per kilowatt. There are many different reasons for the difference in cost. Firstly, Redox Power is more efficient. It is designed to run on mostly gas, but can also create power using different fuels. At its maximum efficiency, the cells can output heat and electricity at 80% efficiency compared to Bloom's 60%.
Redox Power also has a different electrolyte that still manages to be efficient at lower temperatures. Bloom Energy is believed to use the standard yttria-stabilized zirconia electrolyte, but attempt to address the temperature problem by adding a second electrolyte, made from scandia-stabilized zirconia. This overcomes the steep reduction in the yttria-stabilized zirconia's conductivity at lower temperatures. However, scandium is a very rare and expensive earth metal. Redox, on the other hand, are believed to use a cerium oxide and bismuth oxide, which are cheaper than scandium. They also have a higher conductivity. Another advantage for Redox Power is the reduced cost. Since the Cube operates at 600 degrees Celsius, but Bloom Energy runs at around 900 degrees Celsius. Redox uses stainless steel interconnects that cost less and are less prone to thermal expansion, compared to Bloom's porous ceramic interconnects. The lower temperature also results in easier sealing, quicker startup, and greater stability.
Redox have produced a 25 kilowatt prototype. The Cube is targeted to be built to fill the constant power needs of buildings at a price that can compete with grid power. As the Cube will be connected to the gas line, a blackout or electricity shortage will have no effect on its ability to provide constant power. There are many markets where the Cube's ability to provide large, reliable amounts of power are available, such as remote cell phone towers, larger vehicles such as buses or heavy-duty trucks. Redox has recently partnered with Microsoft and the University of Maryland and to receive $5 million from a government grant to test their fuel cell technology in Microsoft's data center. This could possibly lead to Microsoft running their data servers on SOFC, similar to how eBay, Google, and Yahoo servers are run using Bloom's energy servers.
To conclude, Redox aims to revolutionize the commercial SOFC industry and become the first profitable SOFC company. So guess what? The future is looking bright.